Hello guys, my name is Max, and welcome to this video today, where we're going to create a simple Flappy Bird clone using JavaScript and HTML. And we will create it so it also will work on both mobile and on desktop. So the first part of the series will be just us creating the actual game, and then I will do a second part as well, where I show you how you can change the JavaScript, CSS and HTML to an APK or iOS app file, Android or iOS app file using the Relay Cocoon.js framework that I have sort of looked into how it worked and stuff like that. But let's get started with the first part of the series. That will just be the creation of the actual game. So to start off, just if you want to follow this tutorial, just go to my GitHub page, and in my YouTube tutorial repository and in the Flappy folder here you can see a starter folder with just some starter files for this particular project. And that just include an index file with some basic metadata that sets the viewport and actually say that this is a web app, and some styling as well. And we also have this sheet image with the basic graphics for the game, and a sprite file that just sort of load all of the sprites in the sprite sheet for us. And I just do this manually, so yeah, and I thought that wouldn't be so fun to watch, so I just put that into the start file. Anyway, let's get started coding our game now then. So for this time, I will use this sort of syntax where I specify the var keyword up here, and then I can say canvas, context, width and height and stuff like that. That will be inside, or that will be prepended with this var keyword here. So these are all variables like so. And we'll also need some variables here that will set to 0 at the start. So our frames variable, a score variable, and a best variable that will be set to 0. And then we'll use a state machine in this sort of the same way we did in the Astro game, but not as big. So we just take the current state here, and we have the states object here. So we have the splash state, and I'll set that to 0. The game state set that to 1, and then we have the score state that we set to 2, like so. Then we'll of course need a bird, so we say bird, and that's also an empty object for now, and then the pipes object, like so. And here we can actually close off the variables that we declared like that. So we will also need some game functions here, so we have a main function, a run function, and an update function, like so, and lastly a render or draw function, like so. And in that area, just make sure we call the main function so the game actually starts here. And let's just space it out a bit, like so. And we can start with the main file for now. So we set the canvas, create it, so we say document.create elements, canvas, like so. And let's set the width to the width of the window, so say window.innerWidth, like so, and the height to the inner height of the window, so say window.innerHeight. Then we can say here to check if it's a mobile device. That problem means that the width is less than let's say 500 pixels. So if the screen size is below 500 pixels, then we can be pretty certain that it is mobile we are dealing with. So then we have set the width to, let's say, 320 pixels and the height to 4. Oh, sorry, this should be bigger than 500 pixels. So if it is a desktop, that is, sorry, I got that in the wrong way. So this is just to set a basic size for the canvas when we are inside of a desktop environment. And we can also set some styling here while we are on a desktop. So let's set a border style. So you say canvas style border, and we set 1 pixel, let's say solid, and let's say black for the color, like that. Now we just set the width to the width and the height to the height of the canvas here, like so, and grab the context. So say context equals canvas, get context 2D, like so, and let's append that. Append the canvas to the body of the document. Document.body.append child canvas. So for now, if we just open this up in a browser, we should see the canvas drawn for us in the middle of the screen. So that's good. But let's open up the console to add some debugging later on. We'll probably get something wrong doing this game. But anyway, let's continue. So after we have appended the canvas to the document, let's create this image object here. That'll just be equal to a new image. That's of course the sheet image here that we're going to load. So say image on load, sorry, should be a dot on load here. So that equals to a function like so. Let's just set the source here before we do anything else. So say res sheet.png, like that. And let's just log out the message to see if it's actually our loading. Yeah, so the image are loading, at least the test message is written out. So when the image are loading, we just want to call this init sprites method that is in this sprite.js file that we include here in the head of the HTML5. So let's just call that, and let's call the run method. And as a parameter, this took the image object, so or the image object with all of the with the graphics we're going to use. So let's here this image parameter there. So let's just say you can say this here, since this is pointed towards this object, which is of course the image we are interested in, like that. So let's do a loop function real quick. So inside of here, sort of that, we will just call the updates and the render methods or render functions. And then we use window request animation frame for our looping here. So say with the loop and the canvas as arguments there, like so. And let's just draw one of the sprites to the canvas real quick. So you can say let's draw the background image. So we can say BG, so S is just means that it's a sprite. I just use that convention here, and all of the names are here. So the bird sprite, that's actually a list of 3 sprites, all of the different frames, and then we have the background sprite, foreground sprite, the pipe sprites, some text, a text object with all of the text sprites, and so on and so forth. Anyway, let's draw the background. So we say s.bg.draw, and that took the context and a position and where to draw it. So let's draw that 0, 0 now. Hopefully now, yeah, it seemed to work. So we have the background drawn, but we want it to be drawn down here. So for doing that, we just take the y position here. We take the height minus the height of the background sprite. Yeah, so now it is down here, but as you can see, we miss a bit here to the right. So let's draw one more background, like so, but this time let's offset it from the left by the width of the background sprite. So now we have the complete sprite drawn like that. But we probably don't want a white background, so to do that, I just took the background color here and saved it to the background as well, so as an additional property here to the background. So we can just say context.fillStyle equals, actually we can do that inside of here. So here we can say context.fillStyle equal to the bg.color, like that. So we have that done, and then we just fill the complete canvas with so we draw a fill rectangle on the complete canvas. So we say 0, 0, and the width and the height feels like so. And that didn't really work, so let's see what that can be about. Let's drag it up here and see if that works. Oh, sorry, it isn't initialized, so we need to have it below here, below the init sprites method. So hopefully now it should work. Yeah, so now the background is drawn as well. So let's draw the foreground real quick, or let's draw the foreground I should say. So s.fg.draw, and that draws to the context, and that's 0 for now at least, and that's the height minus the height of the foreground, so that should draw it like that. And then of course the same concept as above here, we just offset our second one with the width of the foreground, like that, so we have that done. So that's cool, but we probably don't want it to be drawn at 0 at all times. We want the position to be updated here, so let's create this foreground position. Actually we can save it. Yeah, let's call it f foreground pos, like that, and let's have it here as well, so we have foreground position plus the offset, like that. And let's create that variable on the top here as well, so we have the foreground position, so foreground pos, and let's set that to 0 at the start as well. And then the update, we just update the foreground position. So you say foreground position plus equals, and here we say the frames modulus, some constant here. Well, actually no, we do not. So we say foreground position plus, you can say equals, actually equals foreground position plus 2, and then modulus some constant here that we will figure out. I just said 10 for now. But we should actually increment the frames each update here, so do that as well. Anyway, so for now the foreground should be moving, yeah, but it's moving in the wrong direction, and I think 10 here is a bit too small, so let's try 12, see what that looks like. A bit jerky as well. Let's try 14. Yeah, so 14 seems to be the right modulus there for you, and you can see that it runs smoothly across the bottom of the canvas. So that's cool. So we now have the basic background drawn. So let's draw the bird now. So that's simple enough, but we of course first need to create these objects here. So you have an update method like so, and we have a draw method as well. And we can, on that we will also have on both of the pipes and the bird. But we will start with the bird here. So we have an X position, and that won't actually change, but I will set that to 80 for now. A Y position, let's set that to 0, at least for now. And then we'll have a, we'll have a frame variable of which sprite it's going to draw. So it's called frame. And then we'll have an animation sequence, and this is which order all of the sprites are going to be drawn. So the first, and if you look here on the sheet image, it have 3 sprites, so we want to draw the first sprite once, and then the second sprite, and the third sprite, and the second sprite again, and then start with the first again. So we can say 0, 1, 2, 1, like that, to get the animation sequence that we are the animation sequence, like that. Then we'll also have a rotation, and we'll set that to 0 at the start here, and a gravity variable here, so and the gravity of what the bird is, yeah, which is affecting the bird, like that. And then it also have a jump variable here. So each time we press down, so how much the bird actually will jump up, like that. And speaking of jump, we also have a jump method that we will call outside of the bird. And in here, we can actually do that first here. So we just say this.velocity that I actually didn't create. Anyway, velocity, and that's just equal to minus the jump constant, like so. So let's just set the velocity here as well, and let's set it to 0 at the start. So, but let's but first, before we do anything in the update though, let's just create the draw function to see if we can draw the sprites. And let's say that it take a context as a parameter, like that, and then we just draw the sprite. And for this one, since we are going to rotate the sprite, we will use the context save and restore methods. Sorry, the translate and rotate method of the canvas rendering context to these. So we say context.translate, and it is actually, so we actually translate the complete coordinate system using this method. So we say context.translate, and let's translate it to the x and y positions. So say this of x and this of y, like so, and then let's rotate the context. So say this dot rotation, and then let's draw the image. So say context.draw image. Also, sorry, we should draw the canvas. So we say or the bird sprite. So we say s bird.draw, like that, and with the context like that, and then we say half of the width of the bird for the x position, and half of the width, sorry, half of the height of the bird for the x for the y position, like that. And as I said, the bird is this list of sprites, like that. So we will of course need to specify which frames we're going to draw, and here we will say this dot frame, and this is of course this index up here. So that's it for the draw function of the bird. So let's see if it works. So we can just go down here below the, actually above the foreground layer, and we can say bird.draw to the context, like shoe. So let's see if it's drawn. Well, it wasn't drawn really, so let's see what that can be about. So let's try to just set 100 here for Y position. Nope. 1 second guys, and I'll debug it, then I'll be back. Yeah, and I figured out the error here. This of course is a null error here, since we are just saying s.bird dot the width and the dot height. We of course need to say which an index here as well. So for that, let's actually use this n field here. So that we said it's up here, so we say that's just equal to this dot animation, and sorry, and this dot frame, like that, to get the right animation frame that we are interested in. And up to now, the bird should be drawn to the canvas. Yeah, and here you can see that the bird is drawn. So let's make the position update a bit here. So for that, we'll use this sort of in the update method. We can say here, we can say, yeah, let's just say, let's check if the current state here. So say if the current state is the states dot splash. So in the splash we want the bird to flap with a lower frequency than we want to do when it's in the game state. So we can say if the current state is the splash state, let's actually set the current state to the splash states in the main method. So down here, so let's just set the current state. So say current state equals states dot splash, like that. So now this n field here should have 10 in it, and then we'll set the frame. Sorry, increment the frame here. If the frames modulus, this n constant here, is equal to 0, then we want to increment it. Else we just want to keep it at the current frame. And then so we loop over over what do you say? So we start from the start when the frame is when we are going to the end here. So we say we just modulate this the length of the animation sequence. So they say this dot length. So this is the animation dot length, and of course we don't call the update method. So let's do it. So we say bird.update, and let's actually call the pipe.update here as well, and the pipe.draw down here with the context as a parameter. Yeah, so now we can see that the bird is flapping, or yeah, whatever that's called. So that's cool. So yeah, so let's update the position a bit, and we can do that here in the update method as well. So you just can say what do you say? We check if the current state again is the splash state. So we say state.splash, and then we set the Y position to the height minus some constant here. So let's say 270 or yeah 280 maybe, and then we can say plus 5 times math dot not meter math dot cosinus of the frames field of frames variable divided by some constant here to ease it out a bit. And let's just set the rotation here as well to 0 when we add it here. So now the bird should be moving up and down like that. Just one second, guys. Be right back. Yeah, sorry for that, guys. I'm back. So yeah, we now have the bird drawn to the canvas as well. But we will want some more stuff to be drawn to the canvas when we are doing the when we are in the splash state. And just one small tweak here. I think the bird is a bit far to the right here, so let's just say 60 instead here. Yeah, I think that's better. Anyway, so we go down to random method again. Down here we can say, let's say here after we have drawn the pipes and the bird, I actually can do it all the way down here. So we say if the current state again is the splash state, so we say states.splash, like that. Then we want to draw the splash screen, so we say s.splash and .draw like that, and to up to the canvas of course. And then we want to center it in both directions, so we say let's just calculate the center of the canvas here first. So say width 2 equals to the width over 2, like that. Now we can say width 2 minus the height of the splash screen sprite. So we say width like so. And for the X position, so for Y position, let's set height minus 300, and let's see what that looks like. Yeah, so that's the what do you say? That sprite drawn to the canvas. Then we also want to draw a text to the canvas, so we say text.draw to the context again, and then we say width 2 minus and of course we want to specify which text we want to draw here. And as you can see here, the text is have this sort of JavaScript object, so we will draw the get ready message. So it's a just text s.text dot get ready dot draw like that, and then we want to have the width of that text again, so we will just say it like so, and then the height minus some constant here. Let's say minus 380. Let's see what that looks like. Yeah. So that's all for the splash state. So let's do the game state now. So yeah, that's quite simple. We of course need to, first of all, we'll need to have a mean to transition between different states, And now, so for that we just have this onPress method here, so we say function onPress, like that, and that will take a event here as a parameter. And inside of here we just do a switch of the current state. All the cases here, so here are the cases states dot splash, case states dot game, of course, and we have this states dot score, I think we call it, yeah. And here we just call it break for now, like that. So we have that on. So when we are pressing and the current state is the splash state, then we want to set the current state to the game state. So we say states of game, like that, and we also want to make the bird jump. So we say bird.jump, like that. In the game state, we only want the bird to be jumping, so we say bird.jump, like that. And in the score state, it's a bit more complicated, so we will leave that empty for now, at least. But we haven't set this method to any event yet, so let's do that. So if it is a web browser, then we want to listen for the mouse down event, so we say add event listener. We can actually do it like this, so we say bar event equals, also we can call it edt, like that, and we set that to touch, so like this, touch start at in the normal case here. But if it is the web browser, then we say mouse down, like that, and then we just add an event listener, so we say document.add event listener, like so, and we will listen for the event, and we want to call the onPress method when we are calling this. So up to now, when we click on the we have some errors here, so we say add event list. Let's try again. Yeah. So now when we click on the canvas, this background, the splash screen should be removed. Yeah, and that seems to be the case here. And as you could see, the bird is actually flapping a lot quicker now. But we haven't done any updating of the bird in the other than in the splash case. So let's do that. So let's just go back up to the update method, and here we can say else here. So if it's not the current state, if the current state is not the splash state, then we want to update the bird normally here. So we have saved this dot velocity, add a gravity constant to the velocity, yeah, like that, and this should of course be this. Then we add the velocity to the y position, say this dot velocity, like so. Then we check some errors here, so we check if the y position is bigger than the height of the position of the foreground, so we say like that, and let's say -10 for some offset here. Then we just want to set the y position to the height, to the same position here, so we say f height -10, like that. I don't know why I misspelled this all the time here today. Anyway, and if this is the case, then we also want to make sure that we set the current state to the score state if it's not already, if it isn't already the score state. So you say current state equals states dot score state, like that, and then we'll set the velocity here to the jump speed here, just to make so this velocity here won't grow out of hand here. Anyway, so we have this done. So then we just check here we will do the rotation, or actually we can see what it looks like now. So now you can see here that the bird is jumping like this, but we also want to implement the rotation. So let's do that. So for doing that, we'll say if the velocity is bigger than the jump speed, or equals to the jump speed, then we want to set the frame to 1, so we don't want the bird to flap anymore. And then we set the rotation fill here to the minimum value between the mat over .pi over 2, so the maximum angle can only be 90 degrees, like that, or the rotation plus plus some constant here, so let's say 0.3 or something like that. And else, so if the speed is, if the bird has some upward momentum, then we want to set the rotation to, let's say, negative 0.3 maybe. So let's see what that looks like. Let's reload it, and yeah, now we can see that the bird is actually rotating like that, and that it's, yeah, when it's below a certain velocity here, that it dive like that. And then if we have the game over state like that. But when we are game over, we probably don't want to update the foreground position. So let's fix that real quick. So let's go down to the update method. And here we can say if the current state is not equal to the states score, then we want to update the foreground position. So let's see if it works. So bam, yeah. Now that is done at least. And the same goes for pipes. We don't want to update the pipes position when we don't have the when we aren't in the score state. Or actually, we only want to update the pipes when we are in the menus in the game state. So we do it like this instead. So say when the current state is the game state, then we want to update the pipes. So we say pipes.update like that. Speaking of the pipes, let's do those real quick. So the pipes, we only have one in members here, a pipes list like that, and we also have a reset method where we just clear the pipes. What do you say? The pipes array here. So we just set this pipes to an empty array like that. So let's do the draw function first, maybe. Yeah. Or maybe let's do the update actually. So here we can say if the frames modulus, let's say 100, so each 100 frames, or 100 pixels in this case, we will push a new pipe to the pipes array. And the position of the pipe and stuff like that's a bit yeah, arbitrary to set there, but sorry. So we have set the top position here. Let's set that to the height minus the height of one of the pipes. It doesn't really matter since both the south facing pipe and the north facing pipe are both 200 pixels tall like that, so actually 400 pixels, since we are multiplying the width and the x and y position share by 2. But anyway, so the height of the pipe, like that, I think, yeah, plus the foreground height, the height of the foreground, yeah. So this is just where, this is the y position where I want the pipes to be drawn. So let's actually call it y like that. And then plus some constant here, let's say 120, and plus the random position here, so say 200 times math.random. So this is just to set the y position randomly within the border of the game. And then we just append a new object here to the pipes array. So we say this.pipes.push, like that. And let's set an X position, and let's set that to something outside of the canvas. So let's say 500. And then set the Y position to the Y field we just created. Calculated, sorry. And let's also set a width and height here later when we're doing our collision detection. Not just the the width of the pipes, and the height here, of course, the height of the pipes, like that. So that's it for the creation of new pipes. Then we just update all the pipes. So we say for var I equals 0, len equals this.pipes.length, like that. I is less than len, and then I++, like so. And we just take out the current pipe, so we say this.pipes at I, like that. And then we just update the position. I think, yeah, so we say p.x plus equals, minus equals, since we're going to the left, like that. And then we just check here if the x position is less than, let's say, minus 50 here. So if it's outside of the canvas, then we want to remove that pipe from the pipe array. So we say this.pipe.splice at I, and we want to splice one object. And then we just want to decrement the length and the I fields, like so. So that should be it for the pipes, at least for now, before we do any collision detection and stuff like that, which is quite important in Flappy Birds. But anyway, let's do the draw method. So we can just copy this for loop here, since we don't want to type it all the time. And inside here we just take out the current pipe here. So pipe this.var p equals this.pipes at I, and then we want to draw it. So we say spipe_south.draw, like that. Then we want to draw to the context and a p.x and p.y position. And we want to draw the north facing pipe as well. So you say north, like that. And for the Y position here, we just want to add the gap between the two pipes. So let's say 80 pixels plus the height of the pipe, like that. So for now, we should see the pipes drawn to the canvas, if we have done this correctly. And that seems not to be the case here. So I will just debug this really quick, guys, and I see when I'm back. Yeah, I'm so stupid. I didn't really even realize it. I've written all this in the reset function and not in the draw function. Shit, that's so stupid. Anyway, I just added it to the draw function, and let's see now if it works. And it still doesn't work, so bear with me, guys. I'll be right back. Yeah, and I still had the empty of the pipes there. I'm so stupid. Let's see now if it works then. Yeah, so now you can see that the pipes are drawn. Sorry for that, guys. I'm so stupid. Yeah. So we are closing up to the end here, at least of the first video of this. This was a bit longer than I expected, and I have other things to do today. So I will actually split it up in 2, maybe 3 videos. So yeah. But let's just finish the collision detection, so we have that done at least, and then we'll finish the rest of the game in another video. So let's do that. So let's just go up here again to the update method, and the collision detection we are going to use here is a circle rectangle collision. This can be a bit complicated, but yeah, it's pretty straightforward. But anyway, we check here, we say if I is equal to 0, so if it is the front most pipe, that's the one we want to check collision against, then we use this, then we calculate the closest X position using this clamp snippet here that we have used in many other tutorials, like like the restriction of the, what do you say, the paddles in the Pong game and stuff like that. Anyway, and the values we want to check against is the X position of the bird, the pipe position, and the X direction, and the maximum, the X position of the pipe here plus the width of the pipe, like so. Then we have two Y positions to calculate here, so you say math. So we clamp again here, so you say clamp like that, and we say bird.y, p.y like that, and we have p.y plus p.height like that, and this should be the, what do you say, the south facing pipe. Then we have the other one, so you say clamp again here, and for the values this time we do we want to check against the Y position, of course, still. And we have the p.y plus the p.height plus 80, since the offset is 80, I think. If we do that in the grommet, yeah, so 80 here is the offset. And for the max position, that is of course just equals p.y plus 2 times p.height plus 80, like that. And that should give us the closest positions, like that. And then we want to do two checks here. But first we want to check the difference in the X and Y positions here. So you say bird.x minus the closest X position. And then we have two Y positions again to check again. So you say bird.y minus cy1. And the same here for the delta 2 position here. So you say cy2, like that. And then we have the two distance here. So yeah, and this is sort of the equation for a circle or Pythagoras theorem we are using here. But anyway, so I have the distance 1, and that's just dx times dx plus dy1, sorry, plus dy1 times dy1, like that. Then we just change this to 2's here, like that. So we have that done. And then we just want to return here. So you say bird.radius. Actually, we can call r here first to say r equals bird.radius times bird.radius. We don't have this radius field yet, but we'll soon add it. And we want to return if r is bigger than d1 or r is bigger than d2, like that. Then we want to set the current state to the score state. That means that the bird have been hit. So let's just do this radius field on the bird real quick. So we say radius for the collision circle here, and let's set that to, let's try some different there. So let's try 12 for now, and just so we can see the what do you say, the circle for now. Let's just draw it out to the context of begin path here, sorry, and the context of stroke, like that, and then we'll say context.arc. I think that's the method. Anyway, we will soon see 0, 0, and this the radius here, and then between which angles we want to create here. So say 2 times math of pi to get a complete 360 degrees, of course. Let's see if it works. Yeah, so you can see that the bounding box of the bird is drawn a bit subtle, and yeah, you can see if when we hit the pipe, the bird is dying. So let's do it like below here instead, I think, and let's draw it with the fill. Yeah. Anyway, let's just set the fill style as well, so just so we can see it. Just so we can see it here. So you say context of fill style, let's set it to red. So you can see it. Yeah. So you can see that's the collision we are the bounding box of the bird. Yeah. And you can see that the game is as annoying as it is on the mobile phone. Anyway, so I think that's it for this video. So I thank you for watching, guys, and I hope I see you in the next video. Yeah, so that's it. There's one thing though. Let's just draw what do you say? Let's draw the bird in front of the pipes. I think that looks a bit better when we are dying here, so let's test that. Yeah, so that's it. Thanks for watching. Bye.